Traveling from point to point, from city to city, we're normally interested in getting there in the most direct and fastest way. The fastest route is the most direct route. In this project, we'll be taking a look at traveling by right triangles. Hopefully you'll have fun in seeing how right triangles can be used to be able to get from one point to the next in the fastest, most direct way possible. Now let's explore. Taking a look at a normal map, maps are made up of several components. Maps include a coordinate grid that are based on the concept of a coordinate plane, y-axis and x-axis, giving us specific points along the coordinate grid from the intersection of the x-axis and y-axis. Maps also have what's called legends, from which we can determine how far we have traveled or how far we must travel from one point to another, such as in this map, we can determine our distance in miles and our distance in feet. Now, if we wanted to travel from Farmers Branch in this map to Irving and determine how far it is exactly from this point on Valley View Lane to this point on Valley Ranch Parkway, we'd simply take our legend in feet and measure it, or take our legend in miles and lay it along the length of the path that we would travel and come up with an estimate of the number of miles and or the number of feet between the points that we'd want to travel. Now, let's take a look at the map as a whole. We want to travel from Carrollton, which is at the very top of the map, to Irving, which is at the very bottom of the map. To travel from Carrollton to Irving, it looks like the most direct route to get there, the fastest, most direct way would be to travel MacArthur Boulevard straight down into Irving. Traveling from city to city is the same type of situation. When pilots decide to map routes to get from one city to another, they normally map the most direct route, the shortest route. Just as traveling out MacArthur Boulevard is the shortest route, would be the fastest and the shortest route, the most efficient route to get from Carrollton to Irving. Now, let's take a look at traveling the most direct, efficient route on a broader perspective. Let's take a look at getting from Dallas to Disney World. A straight line drawn from Dallas to Disney World on a map will simulate the most direct, efficient route to get there, to be able to get there the fastest, because we know that the shortest distance between any 2 points is a straight line. We can determine this distance simply by calling our library or looking at an area map or consulting with AAA and find out that the direct route distance from Dallas to Orlando, Florida is 851 miles. But to be able to figure that out for ourselves on a map, we can use the concept of right triangles. If we draw a right triangle using our direct route as the hypotenuse in a right triangle being the side opposite the right angle, one leg being the distance from Dallas to Houston, the other leg of the right triangle would be the distance from Houston to Orlando, causing us to create the right triangle labeled ABC. Now, we have an idea of what the length of our line AB is already from having called and done research. But to be able to figure that out using right triangles, we can first find the distance of side A, the distance from Houston to Orlando, simply using the mathematical form of the absolute value of x2 minus x1. Then we'd find the distance from Dallas to Houston. Since that's along the y-axis, that line is parallel to the y-axis, we would have the absolute value of y2 minus y1 equaling that line. To have our x and y values to go into these forms, we'd have to have coordinates at the vertices. We'd have to have a coordinate at this point, a coordinate at this point, and a coordinate at that point. Knowing that coordinates are nothing but ordered pairs that we'd get from the actual grid map that this particular triangle would appear on. The coordinates from this point and this point, the y values would give us the absolute value of the y values of the coordinates from this point and this point would give us our side B. And again, the y values, the x values, from this point to this one would give us our side A. Since we'd have formed now what's called a right triangle, we all know that a right triangle distances can be found using what's called the Pythagorean theorem. The Pythagorean theorem in a right triangle is the sum of the squares of the lengths of the legs equal to the square of the length of the hypotenuse. The proverbial c squared is equal to a squared plus b squared. Now, since we've discussed the Pythagorean theorem, let's talk about the converse to that. The converse of the Pythagorean theorem is if a triangle has sides, lengths, a, b, and c, and a squared plus b squared is equal to c squared, then the triangle is a right triangle with the hypotenuse of length c. Okay, let's apply this information to traveling and to be able to determine, without having to do any research, how to get from Dallas to Orlando in the most efficient way and the distance we will have traveled when we do that. Since we know that side A is represented by the absolute value of x sub 2 minus x1 squared, and side B is represented by the absolute value of y2 minus y1 squared, and the Pythagorean theorem is c squared is equal to a squared plus b squared, we can figure out our distances by simply using substitution, leaving us with c squared equaling the absolute value of x sub 2 minus x sub 1 squared plus the absolute value of y sub 2 minus y sub 1 squared, with our a squared plus b squared being substituted by the actual coordinates found along the x-axis, the x values from this point, and the y values from this point and this point. To find the actual c side, since we're not interested in c squared, we want the actual c side, the hypotenuse of the right triangle. And by the way, the hypotenuse of the right triangle is always labeled c. And remember, your hypotenuse is always the line that's opposite the right angle in your right triangle. The hypotenuse is always the line opposite the right angle in your right triangle, and that hypotenuse is always labeled c. We find that we can take the square root of x2 minus x1 squared plus y2 minus y1 squared to find c, since c squared was the absolute value of x2 minus x1 squared plus y2 minus y1 squared. Now, that gives us what's called the distance formula. And the distance formula is nothing but a radical equation, an equation that has variables under the radical. C equals the square root, which is a radical, of x2 minus x1 squared plus y2 minus y1 squared. Now let's apply our knowledge. Let's actually find the distance from Dallas to Orlando. Since we know that the distance from Dallas to Houston is approximately 243 miles, and the distance from Houston to Orlando is approximately 851 miles, a squared plus b squared gives us c squared equaling, after having squared 851, of course you know to square a term you simply multiply it by itself, giving us 724,201 plus 59,049. C squared equals 783,250. To find the C side of that right triangle, the distance we travel in a direct route from Dallas to Orlando, we take the square root, as we learned earlier, of 783,250, and that would give us approximately 885 miles. Now there's another way to do that. Let's take a look at using what's called the multiplication property of square roots. And that is, for any numbers a greater than or equal to 0, b greater than or equal to 0, the square root of a times b equals the square root of a times the square root of b. Let's apply this. The square root of ab equaling the square root of a times the square root of b, applying the distance that we came up with for our c squared, would give us the square root of 783,250 equaling the square root of 25 times the square root of 31,330. The way we came up with that was we looked at the number 783,250 and determined what perfect square we could find that is a factor of the 783,250. The perfect square factor we came up with was 25, because we know that 25 times 31,330 equals the 783,250. This is how we use the multiplication property of square roots. If we would enter the numbers, the square root of 25 being 5 times the square root of 31,330 in a graphing calculator, we would end up with a number that would be approximately 885. Now, all of these types of ideas we have discussed have been called and are called square root functions. A square root function is just simply a function that involves a radical. Y is equal to the square root of any number. Let's extend a little bit and find the midpoint. A midpoint is a point simply halfway between 2 points. Suppose we wanted to find the midpoint between Los Angeles and Orlando. We would have to have the coordinate point on a grid for the Los Angeles location from our map, and we'd have to have the coordinate or ordered pair on a coordinate plane for Orlando. We take these 2 points, and of course these points would be coordinate points or ordered pairs labeled XY. Let's just call Los Angeles our X1 and Y1, and the coordinate point for Orlando our X2 and Y2. We take those coordinates and put them into what's called the midpoint formula, where we'd use x2 minus x1 divided by 2 comma y2 minus y1 divided by 2, and that would give us the new coordinate, xy coordinate, for our midpoint, for the point that is in the middle of the line, of the straight line between Los Angeles and Orlando. I hope you've enjoyed the practical uses for right triangles. In traveling by right triangles, we have dealt with the hypotenuse and legs of right triangles. We have talked about and used the Pythagorean theorem to determine the length of the hypotenuse and the legs of a right triangle. We've also discussed the converse of the Pythagorean theorem. We talked about the multiplication property of square roots to be able to resolve a square root and to find the exact or approximate value of that square root, such as the distance it took us to get from Los Angeles to Orlando. We also used the distance formula, the radical equations, the square root functions, and the midpoint formula. Now you'll be given supplemental exercises by your teacher so that you can further use these experiences and expand your knowledge of right triangles. Hopefully, you'll have fun determining your distances to be traveled just as we did. Thank you.